The company claims that this graphene-reinforced filament is the strongest nylon on the market. I did few quick tests and actually they are not far from the truth. Hello, welcome to my tech farm. I have quite special filament on the test. This is Lyten Graphene Nylon Nylon. And I got so many requests from my Patreon supporters to test this filament. And even if it is $150 for 1 kilogram spool, I decided to buy it. But the problem is they don't ship to Europe. So again, I created a post on my Patreon page who can help me out to buy this filament for me and ship it to the Europe. I will pay for the filament and for the shipping. And the Polymaker, they are not only the channel sponsor, but they are also my Patreon supporters because they want access to that extra data and they offer their help free of charge. So they bought this filament for me and send it to me absolutely free. So big thanks to them. And you know, at the beginning I was worried about that the Polymaker will be the channel sponsor, you know, mostly filament testing channel. And but as you can see, I think you as a viewer just benefit from this. And a very important part of our agreement that this don't have effect to my measured results, even if I'm testing Polymaker filaments. Now let's see a few specifications of this filament. This is Lyten PA1205. PA12 is type of the nylon, which is less sensitive to moisture compared to the PA6. I couldn't find information on what is 0.5. Usually companies use this number as the percentage of the reinforcement, but in this case I think graphene needs a smaller percentage, so I'm not sure is this percentage or something else, because usually the PA12 has a density of 1.0203 kilograms per liter, but in this case this is 1.08, which is similar to the ABS or ASA, still lighter than PL and PETG. But I can see that this is some kind of modified PA12. I'm not sure because of the graphene only or they use some other additives too. Another website they claim that this is the strongest nylon on the market with a great tensile, layer adhesion, impact resistance, heat deflection temperature up to 162 degrees Celsius. But these things will be tested in this video. Print settings from this PDF given on the website. Nozzle temperature between 270 and 300 degrees Celsius. Nozzle 0.6 mm diameter, but I'm missing some explanation why. Bed temperature 100 degrees Celsius. Surface smooth PI with the glue or liquid glue. Print speed up to 200 mm per second. Part cooling fan off for all layers except for overhangs and bridges. And drying conditions, I find this 70 degrees Celsius a little bit low, but we will see. I will try to follow these instructions and use brim for large prints. So nothing special about the print settings, only I don't like that I have to use 0.6 mm nozzle, but I don't have additional information, so why. And in the future, if I will have a similar situation, do you want me to use 0.4 mm nozzle for the printing and to see if I will have a clog? Or you want me to follow the instructions and use 0.6 mm nozzle, which I will use in this case. Now let's see what's in the box. Not vacuum packaging, and usually for the nylon companies use that better material, you know, based on aluminum. Bag is not resealable. And we have the card with the print settings, but the same is in that PDF already shown in the video. By the way, because of that lower density, look how full is this spool, and I can see that it don't have hardened edges, so even if it is not too brittle, it cannot go into the AMS units. This is quite weak cardboard on the edges. And at least on the sticker we don't have print informations, but we have the information about the empty spool, 186 grams. Let's see how brittle is this filament. Okay, not too brittle, but let's try to measure it. Start angle 20 degrees. Approximately around 105. So this is not too brittle filament. It will be fine in any printer. And it's not completely broken. Since I don't really like this packaging, I will give it some drying following the instructions 70 degrees Celsius. And in the meantime I started a poll on my YouTube channel asking which diameter to use. And most of you voted for 0.4 mm nozzle, Actually, 2 days later when I checked, it was 62 versus 38%. Now after a few weeks it was a little bit closer to each other, but even then I decided to go with 0.4 millimeters. Following the instructions, drying on 70 degrees Celsius. Slicer settings. I started from generic PACF which exists in the Bamboo Studio. 60 will be the chamber temperature, 100 degrees Celsius on the bed, and I increase the temperatures to 300 degrees Celsius, and 8 will be the maximal flow rate. And the part cooling, only these 2 seconds I increased to 4 because I find those 2 seconds quite short. Everything else, default settings for this material. Start of the printing is good, and I'm also printing from the filament dryer, but to reduce 60 degrees Celsius. Engineering plate with the glue. It will be finished soon, and from here it looks like really nice printing. It's finished, and I have no complaints on the print quality. I'm printing few more test objects. One is for the wearing test in this video, and the other is for the friction test, which will be used in a separate video. My typical wearing test: shaft diameter 3 mm, 2.5 kg is the load, 200 repeats. Wear resistance not like acrylic, for example, which I tested recently, but definitely better than other nylons. Let's check the shrinking, which should be very minimal thanks to the fibers. The design length of this part is 80 mm. Quite accurate. Tensile test with horizontally printed objects. And again, very big question, which material to use for the comparison. I decided it will be average fiber reinforced PA, polyamide, and I have 14 in that summary table, but PPA is not included here. Yes, it is also a nylon, but it is some kind of premium nylon. But looking at these results, maybe I should use PPA for the comparison, but my pattern supporters can do this in just few clicks, because this Lyten is much stronger compared to the average fiber reinforced PA. Layer adhesion, vertically printed test specimens. Layer adhesion, this is my table with the rating for this size of the test object, and we can see according to this the Lyten has fantastic layer adhesion, much better compared to the average PA. By the way, I got few comments why I'm using kilograms for the comparison. Megapascals are always here, or Newton per square millimeters, but I think it's a little bit easier to imagine for non-technical person that, let's say, we have 4x4 millimeters test object and it breaks under 50 kilograms, for example. But the numbers in megapascals are always here. Shear test, I'm starting with vertically printed. For horizontal version, I switched to this stronger crane scale. Printed in horizontal position, fibers always helps in this test, and looks like even graphene helps because this is stronger compared to the average PA. Printed in vertical position, the layer adhesion is very important here, and of course the Lyten is noticeably stronger compared to the average PA. Torsion test horizontally printed. Load and 90 degree rotation. And the maximal load. 2.4. Vertically printed. Load and 90 degree rotation. And maximal load. 1.7. Usually I cannot do this 90 degree rotation with vertical objects. Quite strong in horizontal and in vertical position. In both cases, printed horizontally, usually I record the load in 90 degree rotation, it was stronger compared to the average PA. And printed vertically, usually I record here the maximal load, because in most cases I cannot do 90 degree rotation, but this material was exception, and even here the maximal load was bigger compared to the average fiber reinforced nylon. 3-point bending test. Distance between supports is 50 millimeters, and currently you can see the deformation under 2.5 and under 5 kilograms, and this is under 10 kilograms. Noticeable smaller deformation on the Lyten compared to the average fiber reinforced PA, but what is important is this deformation under 10 kilograms. Yes, even this Lyten has some additional deformation during that 1 minute and it's quite constant, but much smaller compared to the average fiber reinforced PA. And since the permanent deformation is basically 0, I decided to use these test objects for one more testing in this universal testing machine. This is real-time speed, and I will present you soon this machine in a separate video. And it will stop the testing under two conditions, or if the test object breaks, or if it reaches 50% of the peak maximal load, which was in this case. Here you can see the maximal force and the graph, and here the bending strength and elastic modulus. I don't really have enough data for the comparison, but I'm starting collecting these numbers too, the bending strength and elastic modulus, and I think especially this one is extremely good for these 3D printed materials. Creep test deformation and constant load, and this is this nylon. (12.09). So very minimal deformation, but now let's jump 5 days. Day 5, the last measuring. 12.45. Visually no permanent deformation at all. On this graph we can see the distance between two reference surfaces extremely minimal on this Lyten compared to the average PA. Basically it is in the category of the PPA. Let's see the creeping, which is the difference between 2 days, and it's completely deformed because of this number. Let's change this value, I don't know, to 1. Okay, so even now we can see, actually it is not completely 0, so it has that property of the nylon that it slowly creeps even on a day 5, but this is extremely minimal compared almost to any other material. Impact test. I started with the Sharpie standard, and similar break in all 3 cases, and the result in right upper corner. And now this is the ISO standard. And complete break was only when the hammer swing back. And again the result in right upper corner. Result for the ISO and for the Sharpie impact testing, and for the ISO I have a comparison average PA. And usually fiber reinforced materials are very brittle, but not nylons. Well, this Lyten is a little bit weaker compared to the average PA, but this is very good value too. And I check in the meantime, much better compared to the average PPA CF. Temperature test in the oven, and the one on the right side is this Lyten from this video. And I have several tests in the progress, and the first 3 I had to take out earlier. And first surface change I noticed on 168 degrees Celsius, and only later it started with the bending. In summary table I will include the temperature of the surface change. For the Lyten, this is recorded number of the surface change. In theory, the annealing help with the temperature resistance of the nylon. I'm not sure if that's the case with the surface change too. I'm so curious about this material that I want to repeat some tests from my earlier videos. Open end and box end wrench. Let's start with open end side, and I'm measuring the break load in Newton meters. 2.1. And now the box end wrench. 4.9. No break, only skip over, same on the other side. And what these numbers means compared to other materials, well, watch these 2 videos and you will find out. A spring for my future fatigue test, a rag gear, and I will repeat the test from one of my previous videos. $4.21. And again, what this number means compared to other materials, well, I suggest you to watch that video too. The link will be in the description and in the first comment. All results one more time: creep test, tensile test and a layer adhesion, shear test, bending test, deformation after 30 seconds, bending test, deformation under these loads after 1, 30 and 60 seconds, torsion test horizontal and vertical, impact test, temperature test, and this is that new bending test on my machine. Well, this was a new filament type for me again. Experiences are positive. If you compare it with the regular nylons, then definitely this Lyten Graphene Reinforced Nylon is much stronger. Now if you compare it with the PPA-CF, which is theoretically also nylon, in most cases the PPA is stronger, not much, but if impact resistance is important, then definitely this Lyten dominates. Pity that this price is a little bit high and they don't ship to Europe, so huge thanks to Polymaker again to buy this filament and send it to me for the testing. Thank you for watching this video until the end, and happy printing!